in that problem. And this is going to be probably one of the hardest problems there is on the test. There's a problem like that.
Oh, okay.
Okay, just so you know. All right, number 20. And what I'd like you to do on these, Haley, is talk out loud kind of and how you are solving it. In other words, I want to know how you come up with your answer.
Okay. So I'm just making a picture of what it's telling me.
Okay, I'm going to just draw on here. That's 50. Right?
Okay.
Okay. MS is 38. Let's put that on there. And MR is 13. Okay. Now you should be able to answer everything there is to know about this line. Once we've labeled it properly, once we put dimensions on it. So the question is how far is it from there to there? This distance right here.
What?
What's the distance from L to M? Look at the look at my picture.
Yeah.
What is it?
1 second.
In other words, these geometry problems, it's rare that you can get it in one step. You have to figure out something else in between. Always know that. Especially on hard problems like number 20. There's no way this is a one-step problem. We're going to have to figure out another dimension before we can figure out what LR is. They're asking about LR, but we have no way of directly figuring out LR. But notice that if I can figure out LM, then LR is whatever LM is plus 13.
Yeah, so would it be 25?
No. LM,
No?
yes, that's the total. I ask what LM is.
Oh, 12.
Okay. That's easy to get. And now LR is 12 plus 13. But keep that in mind. All the geometry problems you're going to come across are almost certainly two-step problems, or three-step, or four-step. They're never going to be one-step problems. You're not just going to be able to subtract 38 from 50 to get your answer. You had to do that to come up with the 12, but then you had to add 12 plus 13 to come up with the distance between LR. All right, 21. Man, I'm glad I discovered this paint to look at these pictures. It works 100 times better than my old system.
Yeah.
Yeah, it really does. I can scroll down and keep writing. It's perfect.
That's perfect.
Yeah. So, what does of mean?
Like part of, I don't know.
It means multiplication. So 33 1/3% means 0.333 times t equals, means equals 9. So 0.333 is 1/3. So I could write that as 1/3 of t equals 9. Now solve that for t.
Three.
No, Solve that for t. I got t over 3 equals 9. What does t have to be?
Oh. 27.
Okay. So t is equal to 27. Again, this is a problem because we're in the higher numbers. You know it's not going to be a one-step problem. It never is going to be. It's going to be at least 2 steps. So the first step is we got to solve for t. Now, what's 133%, 1 1/3 times 27 equal to? Again, the is means equal, and the of
9.
multiply. What is it?
9.
Use your calculator. Haley, if you don't know how to do it, use your calculator. Anytime
No, well,
you
I'm just.
multiply a number by a number greater than 1, it can't be less than the number. It's got to be more than 27. I'm multiplying it by a number greater than 1.
I keep getting 9.
All right, here's what you want to do. You want to do 1.333 times 27 in your calculator.
35 or like 36.
36. Okay. The reason you kept getting 9 was that you weren't putting that into your calculator properly. You were putting that in as 1 1/3 without parentheses, probably. And it was taking the third and multiplying it by 27, and that's why you kept getting 9. But understand, you always have to apply the test of does it make sense? Can you multiply a number by a number greater than 1 and get something smaller than the number? No, you can't. Ever. So if I'm multiplying 27 by 1 1/3, which is a number greater than 1, I better come up with an answer greater than 27.
Okay, but I'm just confused because on the first equation we did the 0.333 times t equals 9. Now that equaled 27 because wouldn't algebra just be that you would divide it by 0.333 and then get t?
In your calculator, divide 9 by 0.333. What do you get?
2 or 3.
You get 27.
That's not what I'm getting.
Okay, divide 9 by, add more 3's.
Oh, I got 27.
Okay. That's the same thing as t divided by 3, because that means 1/3 times t. And 1/3 is 0.33333. It's easier to actually do if you use fractions and not decimals. In other words, if I make it t over 3 equals 9, now all I have to do is multiply both sides of the equation by 3, and I get that. Now, once I come up with 27, now I got to do the rest of the question. What is 1 1/3 times 27? And I think you got some problems with doing proper fractions in the calculator. You're not doing it correctly. So that being the case, it's better to convert it back to a decimal rather than using a proper fraction. Because if you use a proper fraction, it's tough to do in a calculator. You got to use parentheses, you got to multiply it by 27. Whereas if you use a decimal like 1.333 times 27, there's nothing that can go wrong. You're going to come up with 36 or 35.99999, whatever. But you're going to come up with the answer. All right. Now, And now since I wrote all over the next problem, it's not as perfect as I thought. Kind of ignore my writing for the moment. Let's look at question 22. I don't know how to get rid of my writing. Maybe if I hit this a number of times, it'll delete.
Isn't there just an eraser button?
There is, but if I use the eraser, this is what happens. I erase everything that's on the page too, like that. But I guess that's okay. In other words, now I've erased the question. So just try to ignore my writing. Let's look at this triangle. DE is 1. So let's label. Oops. Huh. Oh, I know. I have to hit on that. Okay. I'm sorry. I'm not used to using paint. Okay.
That's all good.
And let's make it a little thicker so you can read it. Okay. So that side's 1. And DF is √2. Okay. What's the value of the tangent of x? This is one of the 4 trig questions. So first of all, there's some really, really basic stuff you have to know. You have to know Sohcahtoa. Okay. So what's tangent mean?
Opposite over adjacent.
Okay, so we need this side. How are we going to get that side?
You have to do opposite over adjacent, so...
No, hold on. We don't know what that adjacent side is yet. How do you solve? In other words, this is another 2-step problem. Anytime you're in the 20s, you should assume it's not a 1-step problem. It's definitely a 2-step problem. Okay? So the first thing we have to do is solve for that side. Once we solve for that side, then we'll know what the tangent of x is. It'll be 1 over whatever that side is. Well, how can I solve for that side? It's a right triangle.
Isn't it just...
Got to know the Pythagorean Theorem. If there's one thing you have to know for this test, you got to know the Pythagorean Theorem.
Okay.
A squared plus B squared equals C squared, with C being the hypotenuse. So A squared, our unknown side, FE, plus 1 squared is 1, equals C squared is 2, right? So A squared equals 1. What's A equal to? If A squared equals 1, what is A equal to?
1.
Okay. So now we know that side. We can label it 1. Now tell me what the tangent of x is.
1 over 1.
Yeah.
So 1.
So you had to know 2 things here. First of all, you had to know what tangent was. So you had to know Sohcahtoa, because sometimes they're going to ask you about sine or cosine. So you have to know Sohcahtoa. That's a mandatory if you hope to answer any of these 4 trig questions. But secondly, you also had to know the Pythagorean Theorem. But that's also a mandatory. You're gonna run into questions where you have to know the Pythagorean Theorem so that you can solve a right triangle. Anytime they give you 2 sides of a right triangle, you can solve for the 3rd side. Let me test you. What's the hypotenuse?
7 squared plus 6 squared equals C squared.
So, remember, your answer always starts with square root of. It's the square root of 7 squared plus 6 squared. That's what it is. Okay? Whatever that is. 49 plus 36 is 85, so it's the square root of 85, which could be simplified, but I don't care about that. I'm just testing you on your knowledge of square roots or solving right triangles. Now, let me give you another one. This time I'm going to make it 2, 3. Tell me what this side is.
Okay, so square root of x squared plus 2 squared equals
Okay,
3
excuse
squared.
me. Okay, you're right. 3 squared equals 3 equals the square root of x squared plus 2 squared. But that's not really the way to do it. That's not the easy way to do it. That is really hard, okay? The easy way to do it is when they give you the hypotenuse and one of the short sides, then the other short side is the square root of the hypotenuse squared minus the other short side squared. So here's your answer, which is the square root of 5. That's the square root of 5. That is the quick and easy way to do it.
Okay.
And furthermore, it's really important because you're going to have to answer a ton of these right triangle problems. So let's just give you some practice on it. Just going to create a bunch of right triangles, and I'm going to give you 2 of the sides. I want you to give me the third side. I want you to do it in the fastest method. I don't want you to go all the way back to the beginning of the Pythagorean Theorem. That's the slowest method. When you have the hypotenuse, remember, all answers start out with square root of, regardless of which side you're solving. Okay?
Okay.
When you have the hypotenuse, it always goes there. And if you have one of the short sides, it's always subtracting. So there's your answer.
Okay, so 4.9.
And I'm not interested in the
5.
calculator answer. Not really. That is not the answer. The answer is square root of 49 minus 25, square root of 24. So that simplifies to 2 square roots of 6. That's the answer.
Okay.
You do not want to put a decimal answer on there. A lot of these require you to have the exact answer, and the exact answer is 2 square roots of 6. Okay?
Okay.
All right, I'm just going to give you a couple others. This picture right here. Tell me what the hypotenuse is. Don't use your calculator. I want you to tell me what the formula is. In other words, what is this?
Square root of 2 squared plus 3 squared.
Yeah, when you have both short sides, it's plus. When you have the hypotenuse and one short side, it's minus, always starting with the hypotenuse. What's the third side? Don't use your calculator. Just give me the numbers.
Okay.
7 squared, what?
Oh, okay. 7 squared minus 2 squared.
There you go. It's real simple. And there are only 2 cases. There's the case where you have the hypotenuse and one of the short sides, and then there's the case where you have both short sides. There are no other cases. So it's either this, where it's the square root of both short sides squared, added together, or it's this, where it's the square root, and that's always the hypotenuse, and it's always subtraction, and that's always the other dimension that they gave you. So it's one of those two situations. And it is far faster to do it this way than it is to have to go back and say a squared. If you do it this way, it's going to take you an extra 60 seconds. If you learn to do it this way, you'll be speedy. And only because in high school you have to solve right triangles about 1,000 times. And on this test you have to solve them 3 or 4 times. So it's really worth knowing the fast way to do it. And it just depends on whether they've given you the hypotenuse or they've given you both short sides. That's the only two situations. And just always remember that the answer starts out square root of. It may end up being an integer. In other words, it could be an integer if I give you a triangle like this, and that's 3 and that's 4. Well, that is the square root of 3 squared plus 4 squared, which happens to be the square root of 25. So that's 5. So it can end up being an integer, but it always starts out as square root of. Always.
Okay.
All right, and that's the thing to remember. You're always starting out with square root of. All right, let's go to the next page. Now, these are definitely going to be harder. And as you know, your strategy should be the first time through the test, you do all the ones you know how to do. Second time through, you do all the ones you think you know how to do. And if you have any time left after that, you go back and do all the ones that you haven't done yet.
Okay.
Okay? But it's important to be able to determine which ones you know how to do and which ones you don't. So since we're into the relatively hard section here, some of these are going to be hard, some aren't going to be that hard. So I want you to tell me, first of all, do you know how to do this problem? Do you think you know how to do this problem? Or do you think you don't know how to do this problem?
Okay.
23.
I mean, I feel like kind of I could figure it out, but.
Okay. We're going to work on it regardless, but I want you to start thinking in those terms. I want you to start trying to figure out whether this is a problem you would attempt on the first pass through. When you said that you ran out of time on your last one, what do you mean? How many questions did you answer before time ran out of 60?
I would say like, I honestly didn't get through that much. I would say I only got through like 40.
Okay. That's all the easy ones and all the medium ones. There's nothing wrong with that. If you don't get to a single, let's assume that there are 20 easy, 20 medium, and 20 hard.
Okay.
If you guess on all the hard ones, not a problem. It really isn't. That's the best way to get a good score, is to make sure you put your focus on the ones you know how to do and the ones you think you know how to do. Don't waste a lot of time on the ones you don't think you know how to do. If you have time, then fine, go back and do some of them. You can even give some time to thinking about it. Usually what's going to happen is the first 2 times through the test, you're going to be out of time, and you're going to have at best 5 minutes to go back and guess on the ones that you haven't answered. And as you know, that's extremely important. Did you leave anything unanswered when you did it the first time?
Oh no, I just did
So
random.
you timed it properly. That's the biggest mistake you can make on the test, is leaving something unanswered. Okay, so you always want to make sure you time yourself so that you at least have a couple of minutes to guess when you're guessing on all the unanswered questions. All right, this problem, there are going to be two questions that deal with conic sections. And really, the only conic sections are your circle and your ellipse. They don't ask you about hyperbolas. They don't ask you about parabolas. They're only going to ask you about circles and ellipses. So
Okay.
it would serve you to memorize those two general formulas. Here's the n. I'll make it simple. X, well, no, I won't. I'm just going to give you, this is the equation of a circle whose origin is the center. Okay, this question is about that. We've got the center of the circle at the origin, and we
Okay.
have the radius. So all of a sudden we have the full equation. They're telling us the radius is 7. Now, for a point to be on the circumference of that circle, it has to satisfy that equation. Does this point satisfy that equation?
Yes.
Okay, so that's not an answer. Does this point satisfy that equation?
Yes.
Okay, so that's our goal. We're just going to test each of these points. If they work in this equation, then that's not the answer. We're going to find one point here that does not work. Test C. Does C work?
Yeah, it doesn't equal 49.
Ah, there's our answer immediately. There can only be one answer.
Okay.
Once we find a point that does not satisfy that equation, we know we have our answer. Every other point on there, notice that that satisfies it. You square that, you get 26. You square that, you get 23. 26 plus 23 is 49. So every point on there has to satisfy that equation. But the key is knowing the equation. You can't even begin this problem if you don't know how to set up the equation. Now, before we leave circles, I gave you the easy formula. That's for circles whose center is at the origin. If you have a circle whose center is not at the origin, this is the formula. It's very similar, except you have an H and a K, and H and K are the center. So if I had a circle over here whose center was at 2, 2, my equation would be x minus 2 squared plus y minus 2 squared equals, if the radius was 7, again, that would be my equation. So this really is the one you want to memorize. Because if it's at the origin, then h and k are both 0, and you have x squared plus y squared equals r squared. But
Okay.
I have seen questions on the ACT that do incorporate an h and a k. In other words, they will say to you, they'll give you this equation, and they'll say, where's the center? And what's the radius? So you have to be able to work backwards. In other words, if this is the equation they give you, you have to know the center is at 2, 2, and the radius is
Okay.
square root of 49. Now, as long as we're talking about, see, I wish I knew, I will figure this out on how to erase everything I've erased. But until I do, I want to talk about ellipses, because these are the two conic sections you're going to be tested on. A circle and an ellipse. Do you know what the general formula of an ellipse is?
No, what is an ellipse?
It's x minus h squared plus y minus k squared. Looks very similar to a circle. Only it's not equal to r squared, it's equal to 1. And that's divided by a squared, and that's divided by b squared. So it's considerably more complicated. A is the distance from there to there, and b is the distance from there to there. It's kind of thinking like A is the big radius and B is the little radius. Okay?
Okay.
And they will ask you probably at least one question about ellipses. And the only way you have to answer that question, I can guarantee you, is by knowing this general formula. So there's two general formulas you want to remember. And I'll list both of them right now. Take a picture of these if you need to, but you need to memorize these. That's a circle. That's an ellipse. In other words, that's the ellipse general formula. That's the circle general formula.
Okay.
Okay? And whenever they ask you a question about ellipses or circles, you have to start here. Every question I've ever seen regarding them, you have to solve by starting with the general formula. All right, what I'm going to do is go back and reopen this, which is the only way I know how to do it, so I don't have all my scribbling all over it. Yeah, that works. All right, so we did 23. We talked about circles and ellipses. You're going to get 2 questions on those. 24. Now, this looks like it would be a tough question, right? Because it's 24.
Mm-hmm.
Is this a tough question?
Um,
First of all, look at it. Tell me whether it's one you know how to answer, you think you know how to answer, or you don't know how to answer.
okay. I think I would know how to answer it.
You think you know how to answer?
Yeah, would it just be 4 times -3?
Okay, what are the coordinates of A? That's the first step.
1, 4.
Good. And what the coordinates of B?
-1, -3.
It's the y coordinates times each other, so it's 4 times -3.
Yeah, so -12.
Notice that that is an easy question. That is not a hard problem. In other words, that is definitely one you should know how to answer. And yet, it's question 24. It's up there. So you can't always assume that the bigger number questions are hard questions. They're not always. This is really quite an easy one. You just have to put the coordinates on each point. A, pretty easy to figure out the coordinates. B, really easy to figure out the coordinates, and then multiply the y's times that y. -12, okay. Another parallel. The moment you see these, you know you're dealing with parallel lines, even though they don't even say it. In other words, normally they would put the arrows on it like that. But even without those arrows, I know I'm dealing with parallel lines. I just instantly know it. Because they're going to ask you 4 or 5 questions on this test having to do with parallel lines and transversals. And they always try to make it a little confusing. In other words, they don't just give you two parallel lines and a transversal. They give you two parallel lines and two transversals, which confuses you a little bit. It's harder than if they just give you that. So the secret is to kind of eliminate the transversal in your mind from being there. They want to know this angle right here. Well,
Okay.
what's that the same angle as, first of all?
It's the same as like C.
Okay. Now, C is the same. If I consider these to be my two parallel lines, and that's the only transversal I'm looking at, well, then C is the same as what? This angle right here, correct?
Mm-hmm.
What's that angle?
136.
Yeah. In other words, always try to reduce these down to two parallel lines and one transversal, because you always know that that angle is the same as that angle. So I know that this angle is the same as that angle, and I know that C is the same as Y because they're vertical angles. So I have to know a couple of geometry principles here. I got to know vertical angles are always equal, and I got to know that the obtuse angles are always equal. And like I said, this line right here is only meant to confuse. If you can kind of eliminate that from your view and view this problem as this only, well then clearly that angle is the same as that angle. And it's only that other transversal that confuses the issue. But
Okay.
they're always going to do that, especially on questions with a 2 in front of the number. They're not going to make it simple. They're not going to give you this problem up here. They're going to add an extra step to it. All right, now I can go to another page. That was actually two problems in a row that were, I would consider, easy problems that should fall into the category of problems you can do the first time around, and you should recognize it that you can do it. About 26. Can you do this? You think you can do it? Or you can't?
Okay. I can do it.
Good. Tell me how. Go through each step.
You just do negative 3 to the third plus 2, and then negative 3 squared plus 2 parentheses negative 3, and then just solve.
What did I make? I made a mistake here. What was it? I purposefully made a mistake. What was it?
I'm not sure.
Didn't put the parentheses around the first negative 3.
Oh.
That matters. Notice that if I don't have parentheses around that, the middle term, it gives me a different answer. Turns out that I don't lose anything, but you always have to put the parentheses around when you're substituting. So now
Okay.
simplify. What's the first term?
Negative 27.
Second term?
$18
Plus or minus?
plus.
You need the plus. I can't just leave it out. I'm adding numbers or subtracting numbers together here. I can't leave the plus out and assume a plus. It doesn't work when you have a string of numbers. What's the last one?
Negative 6.
Okay. What's that answer?
Negative 15.
Okay. So another easy one. So that's 3 in a row we've come across that were actually quite doable. This one, tell me whether you can do it, you think you can do it, or you don't think you can do it.
I can do it.
Okay, do it. This is tougher than it looks. Go ahead though. You've decided, you're taking the test, you've decided you can do this problem. Let's do it. Tell me how to do it. And you'll immediately run into a roadblock. Go ahead.
Well, I would just distribute.
Okay. That's what most people would do. Go ahead. Tell me
So
what the line is.
RT plus RU minus ST plus SU.
Now what?
I'm not sure because there's no like terms.
Yeah, now all of a sudden the problem has become very difficult. Because I don't know how to match one of these things up over here on the left with that expression. That's because distributing it was not the correct first step. But you don't discover it until you do it. The first step is a very unusual step, but you're going to get at least one problem on the test that wants you to do this. It's a factoring problem. What's the greatest common factor in that expression that I just circled?
1.
It's t plus u.
Oh.
Aha. See, that's because you rarely ever factor out a dual term. What's left over?
Just R minus S.
Aha. Simple problem.
Oh.
Very clever problem, because if you take the wrong first step, you end up in no man's land. You don't know what to do with that. I don't know what to do with that. I would have no idea how to turn that into one of these answers. But what you have to notice when you're looking at this is that you can factor out a binomial.
Okay.
It is rare because it's something that they don't, when you go to high school, you rarely ever, except maybe college algebra, start getting problems where you have to factor out binomials. But this is one, and ACT likes to test on it. They really do. They like to give you a problem where the answer lies in factoring out the binomial term, not distributing. But it's hard to know that in advance. In other words, it's okay to put this in the category that I know how to do that. And then after you do the first step, now you can change your opinion. You can say, wow, I'm not sure I know how to do this anymore. That's okay to have that kind of thinking, because you don't realize until you do that first step that, it's a lot tougher than it looked. Okay. So the first thing let's do is label some of this stuff. Whenever you're presented with a geometry problem, you know, especially number 28, it's probably not going to be a one-step problem. It's probably going to be a two-step problem. From there to there is 4. And they want to know what the area of this little triangle is. So, this problem you can do, you think you can do, or you think you can't do?
I think it would take me a while.
Okay. The key here is this line is parallel to that line. Okay. That means you're dealing with similar triangles. The largest triangle is a similar triangle to the small triangle. So everything is in the same ratio. I left off a measurement. I apologize. Would have made this a little easier. In fact, when I went to solve it, I realized I'm missing something here. Okay. So we know, here's the big triangle. Okay. Which has dimensions 6 and 8. Over here, this is the little triangle. And it frequently helps to separate them like this. I've just found that a lot of geometry problems where they combine figures in one picture, it actually helps quite a bit to separate them. If those two triangles are similar, what is x?
3.
What's the area of that triangle?
Um,
The area of a triangle.
24.
No, it's half.
No,
It's half the base times the height.
I did do that.
Half the base times the height. That is probably the most important formula you need to know.
I did do half the base times height, Joe.
Okay, well, the base times the height is 12. What's half of 12?
Oh, are you talking about the smaller one?
Yeah, they're
Oh,
asking about this triangle here.
I'm sorry, I did it for the big triangle, so it'd be 6.
Okay, I got you. You're right. The area of the big triangle is 24, but the area of the little triangle is 6. So another thing that sometimes is worth doing, because I make this kind of mistake all the time. I don't read the problem carefully enough. So one good thing to do is underline as you're reading the problem so you don't make that mistake. They're not asking about triangle ABC. They're asking about triangle DBF. And if you underline it, it's less likely you're going to make the mistake you made. Now, that can be carried to extremes. In other words, I don't need to underline that because I'm going to label the picture. I don't need to underline that because I'm going to label the picture, and I don't need to underline that because I'm going to label the picture. But once I've labeled the picture, yeah, I definitely need to know which triangle they're talking about, the big one or the little one. And notice how much easier it made it when I separated the triangles. Because now I can definitely see there's a 2-to-1 relationship there. So this has to be 2-to-1. I instantly can come up with 3. And now that's pretty easy from there. So in actuality, I think this was at best a medium problem. Definitely not even a hard problem. The only hard problem we have seen is the one right before this, that 27 right there. A lot of people would get that wrong because they would do exactly what you did. It's just the way most people are going to treat a problem like this, is they're going to do the only thing they see that they can do, which is to distribute. They don't see that you can factor out a binomial because they don't give you that many problems in high school where you get to do that. It's a pretty rare thing to do in a high school problem. I want you to do this in as quick a possible time as you can do it. Right now. Starting, go.
Shoot, I'm forgetting the unit circle.
Don't need the unit circle. Use your calculator.
Don't.
Type
Well, I
in
didn't.
sine of 225 degrees. What do you get?
I got negative 0.7.
So now you have to figure out what answer is that. Because they don't give you the answers in decimal. They give them to you exactly. Which answer is that? It's clearly not that. It's clearly not that. It's clearly not that. We're down to those two choices. Put those in your calculator and figure out which one is 0.7. You don't even need the negative sign. Just
What's the first one?
Yeah. So that problem is a 20-second problem. That's it. But the key thing to realize is that your calculator is always going to give you a decimal answer. It's not going to ever give you the exact answer. But that's okay on this problem. Because it's easy enough to figure out which of the answers that we are presented with equals negative 0.7. That's not hard to do. Just test these out. You can put each one of those, and those are the only two you need to test. You don't even need to test those three. Those can't possibly be correct. Two of them are positive, for one thing. And minus a half is minus 0.5, so you don't need to check that. All right. Okay. These actually aren't the hardest. I forgot we're going 1 to 60. So the hard problems are going to be in the 50s. The medium problems should be 20 to 40. The easy ones should be 1 to 20. But that's going to depend on your skills. In other words, if your skills are extra good in geometry, well, then the easiest problems may not be 1 to 20 for you. There may be some problems like this one where if you have good geometry skills, this is an easy problem. This area is 45 of that triangle. So what is that? What can you tell me from that? The area equals 1/2 base times height. We've got the base of 3. What we need is that height, and we know the area is 45. So what's h?
22.5. So
solve this equation manually. What's the first step?
okay, well, so I know 1/2 times 3.
Oh, hold on, don't do it that way. Do it the easy way. 1/2 times 3 leaves you with a fraction. That messes everything up. How do I get rid of that 1/2 really easily?
Multiply
by 2.
2.
That gives you this. Now, much easier. No fractions involved. So always solve an equation in the manner that doesn't involve fractions if you can avoid it. And I don't have to do 3 times 2 first. That produces 1.5. And then I'm dividing 45 by 1.5. Now I got to get my calculator out. But if I do it the simple way, which is to multiply everything by 2, that gets rid of that, and then divide everything by 3, that gets rid of that, now gives you h, which is 30. What did I do wrong? Because that answer isn't on there, is it? In other words, when you come up with an answer, I came up with the answer of 30. You're asking about that right there. Well, that's the height of that left triangle. Notice, I made a key mistake. It wasn't the left triangle that has an area of 45. It's the full triangle, XYZ, that has an area of 45. So let's do it again. Area equals 1/2 the base, which is what? Of triangle XYZ?
15.
Times the height. We know the area is 45. Now solve that equation.
Six.
That's our answer. Again, like I said, I am very prone to misreading the problems, even though I've done this test 10 times with students. This specific test I've done 10 times, and I still misread it. So I'm becoming more and more convinced that one of the key things you can do by taking the SAT or ACT test is to underline key stuff. If they're asking about a certain triangle, underline it, because we're looking at actually 3 triangles. We got XYZ, we got XYS, and we have SYZ. So there's 3 triangles there. We got to make sure we're dealing with the correct one. Now there's a fine line between wasting time doing stuff like underlying key parts of the question and speed. You don't want to spend all your time underlying. You don't want to underline that. You don't want to underline that. You don't want to underline that, because we're going to enter all that into the diagram. We're going to draw all over that picture. And the first thing I'm going to do is, I don't even need to enter that. That's already on the diagram. So all of that's actually unnecessary information to even consider. It's already in the diagram.
Okay.
The only mistake I made was thinking XYZ was this little triangle over there, and it's not. I just made a key mistake. And the secret of these tests is to not make those key mistakes. It really is, and it's hard to do. Like I said, I've given this test 10 times to people, and I still made it. Okay, so CD is 10. That means that whole thing is 10. They're asking about circumference. So start where?
So you just do the formula. Circumference equals pi r squared.
That's the area.
Oh. 1/2 pi r squared?
Oh, it's 2 pi r.
2 pi r.
Okay? Very key formulas right here. You want to remember only 2 formulas. Those are the 2 you want to remember.
Okay.
Okay, now since they're talking about circumference, we're only going to use this one. They want to know what the circumference is. So what's R?
10. Oh, sorry. 5.
What's circumference?
10 pi.
Another very easy problem. This I would classify as probably the easiest geometry problem on the test, despite the fact that it's question 31. Now, these kind of problems. Take a look at this for a moment. Tell me whether you think you can solve it, you know you can solve it, or you think you can't solve it.
I think I can solve it, but it'd probably take me longer.
Not really. You're right. This is a very easy problem. What do we have to do to that expression? They're asking which of these expressions equals that expression. Well, what would be the one logical thing you would do with that expression if you had to work with it? Factor. Always be thinking factoring. Factor, factor, factor. You're going to have 10 problems on this test where you have to factor. Even that really difficult problem 29, where we had to factor out a binomial, it was a factoring problem. That's all it was. So factor that.
Factor that one or the answers?
Take the greatest whenever you factor anything, no, don't take the answers first. Whenever you factor anything, the first step is to look for a greatest common factor. The second step is to look for difference of perfect squares. The third step is to look for quadratic factoring. Well, the first step works just fine here. What's the greatest common factor from that expression?
Pi r.
What's left over?
S.
S plus.
R.
Very simple problem. You just have to know it's a factoring problem. Also notice that this problem looks as intimidating as can be, right? When you first look at it, you see this complicated looking formula there. They're talking about right circular cones. Oh my God, this must be terrible. A is surface area, who cares? R is radius, who cares? S is length, who cares? It has nothing to do with knowing what any of those are. It is a straight factoring problem. So always have your mind on, can I factor this expression? That's a key first thought to always have. And yes, you can, and that's the answer. It doesn't matter what R is, A is, or S is. None of that's important, or the fact that it's a right circular cone. Had they merely said, there's a formula, what formula is the same as this formula, then you would have known that it was a factoring problem and you wouldn't have been intimidated by all this hard stuff that it looks like they're giving you. And I mean that. I mean, they really go out of their way to make these things look hard. And clearly it's not, right? It's a very simple factoring problem. You have to know that it is not hard. Don't be intimidated by their complexity. It's just a trick they use to try to get you to think it's hard. Slope. Slope is something you want to be very, very familiar with. You're going to ask a lot of questions on slope. What's the general formula that they taught you to deal with slope?
Y equals mx plus b.
Okay. Slope being?
M.
Okay. So we got to take this equation and get it into this format. So solve this equation for y. 3y equals what?
13 minus 5x.
Y equals what?
Equals 4.3.
Don't do it that way. First of all, you don't need that.
Or just be 5.
That first number is immaterial. They're only asking about M. They're not asking about B. So the answer is what?
B.
Yeah. In other words, we didn't actually end up with the right format. We've got it in y equals b plus mx, but that's the same thing. You just have to recognize that slope is always the coefficient of the x term, regardless of what order it's in. Slope, once you get y all alone on the left side, then the only thing you care about is the coefficient of the x term. Now, had they said, what's the y-intercept? Well, then that's an important number. But they didn't. The only thing they're asking about is slope. But again, it's a two-step problem. You have to take their original equation and solve it for y.
Okay.
All right. And you know what these goalposts mean?
Yeah, just the absolute value.
Okay. Now, whenever you see a problem like this, you're probably going to have to check all 5 answers, right? Now, how are we going to check that? Does that have to be true? We're looking for one that is true all the time. So in order to prove that something is not true, is all I got to do is come up with an A and a B that makes this not true, F. Is it always equal to an integer? Can you think of any numbers for A and B? In other words, you're allowed to pick numbers here. And this is a pick numbers problem. Why? Because the question has variables in it and the answers all have those same variables, kind of. Whenever you see that, understand that you can pick numbers. In other words, A and B don't have to be anything. They can be anything. It's just that. So give me an A and a B that disproves F.
2 and 3.
Okay, good. How about G? Can we disprove G? It's hard, isn't it?
Yeah, sorry, I'm just trying to figure out.
That looks like it's going to always be positive, and we know that square roots are always positive. So if I take two positive numbers and add them together, how can it not be positive? Well, there's a
Two positive numbers and add them together, is that what you said?
well, if I try numbers for B and A, this is always going to be positive, especially if I make B greater than A, right? That's got to be the answer. Why is G correct and H is not? You cannot have two answers. What's the problem with saying it's always positive?
Because you could choose numbers that would make it not positive.
Which numbers? There's only two numbers you could ever choose so that it wouldn't be positive. Like I said, this is always square roots of things are always going to be positive, and absolute values of things are always going to be positive or zero. If A is equal to B, it's not going to be positive. It's going to be zero. This would be zero, and that would be zero if A is equal to B.
Wait, so 0 isn't considered positive?
No, it is not. Negative numbers are negative, 0 is considered neither, and positive numbers are positive.
Oh, okay.
So the only one, in other words, I can rule out H because I can pick two numbers for A and B where that's not true. I can make A2 and B2. And then I got 0 plus 0, which is 0, which is not positive. Negative, if A is equal to B, that's not true. We just showed that it's 0 if A is equal to B. And it's always real. It's not always real if A is bigger than B. Because when you take the square root of a negative number, you get imaginary. So it's not K. It's not always real. The only two answers that are even possible are those two. And we just proved that it's not always positive. Sometimes it's 0. But if B is greater than A, then they can't both be the same. And I can't have 0 plus 0. As long as B is greater than A, then this combination has to be positive. Okay? You can do it. You're not sure you can. You think you can do it, or you think you can't do it. I'm going to give you a tip. Tell me the quadratic formula.
Negative B.
You do have to know this also. This is one of the other formulas that they're going to quiz you about.
Isn't it negative B plus or minus the square root b squared plus
minus 4ac.
minus 4ac all over b squared, 2a.
2a, right there. Okay. What's that look like right there?
Product of
Looks like one of those solutions, right? In other words, what this means is you have two solutions. One uses a plus, the other uses a minus. But this looks like the minus solution. What's the other solution have to be?
positive one.
Yeah, this one right here. Oh, sorry. This one right here. We don't change the sign on the 7. The only thing, there's two answers. One uses the plus, one uses the minus. Well, if this is one of the answers, the other answer has to be 7 plus root 17 over 2. That has to be the other solution. And if you know that, this is a 10-second problem.
Okay.
In other words, you're looking at a quadratic that cannot be factored, which means you got to solve it using the quadratic formula. And they're giving you one of the solutions. Well, a piece of cake. The other solution is obvious. It's just a plus instead of a minus. But only if you know that quadratic formula. Although even if you didn't know it, and you were hard pressed, you might figure that out. That when you have a quadratic formula, the two solutions come, and not everybody realizes this. They see that plus or minus, but they don't really know what it means. Well, what it means is one solution is you use the plus, the other solution you use the minus. Okay, problem like this, I'm always drawing a picture first thing. There's the diagonal, it's 20, it's a square. They want to know what one side is. It's a square, what's that?
It's the same as x.
Now, this time you need the Pythagorean theorem, but you can't do it the simple way. They haven't given you two sides. They've given you one side, and the other two sides are the same. So I really do have to go back to the original Pythagorean theorem to solve this. So what works? If I want to put that in the Pythagorean theorem, what is it?
X squared plus x squared equals 20 squared.
Solve it. Again, the calculator is going to hurt you, not help you here. And I can't tell you how many problems I run across that are like that. I'd almost say you're better off leaving your calculator at home than you are using it. It's almost that serious. Do this without the calculator.
Wasn't it just
What's the next
4?
line? Just give me line by line. You're solving an equation.
Also, it's just 4 and then
What's x squared plus x squared?
x to the 4th.
No. That's if you're multiplying, not if you're adding.
Oh, so just x squared?
It's 2x squared.
2x
That's an apple, that's an apple. If I add one apple to another apple, I got two apples. Now keep going. What's x squared equal?
200.
Now what's x equal?
14.
It's equal to the square root of 200, right? Correct?
Mm-hmm.
Okay, that answer isn't on there. So what do we do now? You can either simplify that, or you can just find out what decimal that is and which answer is close to that decimal. What'd you come up with?
14.1.
Which answer is that? It's obviously not that one. It's not that one. It's not that one. It's not that one. God, it has to be that one, doesn't it? Now, do in your calculator square roots of 2 and see if you get the same answer.
Yeah, but how did you know it wasn't going to be K?
Well, it's 15 times a number that's bigger than 1.
Oh.
It's very important when you're doing math to know things like what is the square root of 2, approximately. Is it a number bigger than 1? Is it a number bigger than 2? No, it's 1.4. That's a good thing to know. The square root of 2 is 1.4. Square root of 3 is about 1.7. But whenever you take the square root of a number bigger than 1, your answer is bigger than 1, always. So I don't care what number is in here, whether it's 2, 3, 4, or 5. 15 times it is going to be bigger than 15. But I also could have gone from square root of 200 is the square root of 100 times the square root of 2, which is 10 root 2. So I didn't really need a calculator. I can reduce square root of 200 just fine to the exact answer without using my calculator and finding out what the decimal is of square root of 200. I should say the decimal approximation, because that's what it always is. Whenever you take the square root of a number and it doesn't turn out to be a whole number, you're talking about an irrational number. So if you're going to write a decimal for that number, it's always an approximation.
Okay.
Never exact. Square root of 200 cannot be 14.1. It's an irrational number. All square roots are irrational numbers unless they turn to be whole numbers. All right. Easy, medium, or hard?
Say, I mean, I could do it.
For sure, if your life depended on it?
No.
Yes.
But, yes.
Absolutely. Don't get confused by this. Just ignore that. They're asking you which expression is equal to that. Well, what do you have to do?
You have to factor.
No, you have to multiply them. They're already factored. There's no factoring to be done. You have to FOIL them. In other words, you have a binomial term times another binomial term. You FOIL those. You multiply every term by every term. What do you get? What's the first term?
3a squared.
Keep going.
Plus 6a.
Keep going.
Minus 4a minus 8.
All right. Which answer is that?
C.
Okay. This here that they put for all A, that's math speak. In other words, it doesn't really have anything to do with the problem, and it does confuse people. If I were to cross that out and give this problem, every person in the class would get it right. But merely putting in those 3 words for all A, all of a sudden gets people's minds so they don't work anymore. It's amazing how easy it is for them to get you confused by just putting in some words that don't really have any meaning for the problem at all. And I don't mean you. I'm not judging you. I'm talking about everybody. They put this stuff in there to confuse everybody. They really do. Okay, midpoint. You're going to have a number of problems that refer to midpoints. Sometimes they're going to give you the two endpoints and they're going to ask for the midpoint, which is really easy, right? Let's do one. Ignore this problem for a moment. What's the midpoint between those 2 points?
4, 2.
No. 2 is correct. What's the midpoint between 1 and 5?
Oh, -4.
What's the midpoint between 1 and 5? The way you do it is you add the two numbers and divide by 2. What's the midpoint between 1 and 5?
2.5.
Add the two numbers, divide by 2.
Yeah, 5 plus 1. Oh, 6. Gosh. 3, sorry.
Midpoints are really easy. That's all you ever do. You don't have to consider it an XY coordinate plane. The X coordinate is the midpoint of the two X coordinates. Add the two numbers, divide by 2. The Y coordinate is the midpoint of the two Y coordinates. You add the two numbers, divide by 2. So finding midpoints are really easy.
Okay.
So they make it a little more difficult. They give you one endpoint, and they give you the midpoint. So it's a little harder, and now what they want is this other endpoint, which they're calling 4, S. They want to know what is S. So if 8 is the midpoint between 2 and S, what does S have to be? In other words, we don't care about the X coordinate. They're fine. They're only asking about this Y coordinate right there. And the only thing
14.
we know is that 8 is halfway between 2 and some number S.
Is it 14?
Yeah. And the way I got it was I took the difference between 8 and 2, which is 6, and added 6 to 8. It's real simple. So if they give you one endpoint and a midpoint, then just kind of work your way up, knowing that that point has to be halfway between the X coordinates and halfway between the Y coordinates. And only an S of 14 makes 8 halfway between 2 and 14. 2 plus 14 is 16, divided by 2 is 8. So this is a midpoint question, but it's slightly harder when they give you the midpoint and you have to calculate one of the endpoints. If they give you both endpoints, that's an easy problem. This is probably a medium problem. Nonetheless, this is not a hard problem. It's at best medium. All right, in a group of 3 numbers, the second number is 3 less than 4 times the first number, and the third number is 5 more than twice the first. S is the first number. So they tell you that. S represents the first number. So S equals first number. What's the second number?
Just
3 less than 4 times the first number. How does that translate into an equation? 3 less than 4 times the first number.
Oh, so 4S minus 3.
Yes. Notice again, They put that in the lead when it doesn't go in the lead. They could easily have said 4 times the first number minus 3, but they didn't. And they never do. They always state it like this. It's always the thing that's being subtracted, they always state first. And a whole lot of people, I would say 50% of students, end up writing it 3 minus 4s instead of 4s minus 3. So be very aware of that. When you see these things that are 3 less than 4 times, you know that 3 is being subtracted from the 4 times the first number. What's the third number?
Would be x to the 8.
Reading here, the third number is 5 more than twice the first.
Oh, okay, so s 2s plus 5.
Okay. Now they want the sum of those 3. So you add s to 4s minus 3 to 2s plus 5. What do you get?
6s. No, 7s.
Okay. So that crosses out all those. One of these two answers.
Plus 2.
That's it. And notice that this is an easy problem. This is not hard. You just have to take all these expressions and translate them into an equation. Just seems kind of hard. Now, again, everything that they tell you in the paragraph is already written in this diagram. And you know that because they're giving you a diagram and it's fully labeled, right? And I can see the 80 degrees is on there. The 130 degrees is on there. The 110 degrees is on there. So what are they giving me all this stuff for? I don't need any of that. I'm looking at the diagram. What's the measure of DEC? This angle right there. So that's all I have to know. And I don't see anything that looks parallel. So it's probably not a question about parallel lines. It is a geometry problem that's fairly typical in that all geometry problems are never going to be one-step problems. They're going to be 2, 3, or 4-step problems. So when you have a geometry problem, you don't know what to do, start filling in angles that you know. Can I fill in this angle right there?
Yeah, it's 110.
Can I fill in this angle right there?
50.
Can I fill in this angle right there?
Where?
Why do I know C?
Because it's the same as
triangle
50.
right there, and you know 2 angles. If you know 2 angles of a triangle, you know the third one. What is the third
one?
What do the 3 have to
30.
total?
30.
What do the 3 have to total?
180.
So that's got to be 50. 50 plus 50 plus 80 is 180. Okay, what's this angle right here?
$70.
Aha. Now we have this triangle right here, and we know 2 of its angles. 70 and 50. What's the third one?
60.
That's the answer. Notice I had 1, 2, 3 steps I had to do before I could get to X. And I had to use every piece of information in the entire diagram to answer those first three. But in geometry, if you do not know how to do a geometry problem, just start filling in angles and hope that it leads you to this kind of a situation where you have a triangle and you know two of the angles. If you want to take a break or anything at any point, let me know, Haley.
Okay.
You'll get to take breaks during the test. You can take a 5-minute break. They're not ever going to make you do 2 hours in one sitting, but you let me know.
Okay.
Easy, medium, or hard?
Oh, I would say, I don't know. I mean, I think I can do it.
Okay, so we'll call it medium. Go ahead and try it, give it a shot. When you come across a problem and you're not positive whether you can do it or you think you can do it in the first go around, go ahead and give it a shot. If you think you can do it, I know that I said that do all the ones you know you can do, but that's going to be hard to tell. In other words, it's often very difficult to tell whether you know how to do it or you think you know how to do it. So if it falls in either of those two categories, I would go ahead and give it a shot. Never spend more than a couple of minutes on a problem the first time through. Never. If you're spending more than 2 minutes on it, label it hard and go to the next one.
Okay.
Okay. How do I figure out the percentage loss? How much did I lose? How much did Jack lose?
$30.
How do I figure that as a percentage? What do I divide it by?
I'm not sure.
Always,
200?
always the original, never the new one. Always
Okay.
divided by the original, always. Now your calculator will tell you that's 15%. In other words, it's never divided by the new price. And it doesn't matter whether you're figuring out how much you made or how much you lost. Let's say he sold it for $270. Well, how much did he make? He made 70, and I'm going to divide it by 200. I'm never dividing by the new price. I'm always dividing by the original price, whether it's a gain or a loss. That's the way you figure it out, is always dividing by the original price.
Okay.
Another trig question. It's a little harder, but you can certainly use you can use your calculator for a lot. What is your calculator? How do you solve this with a calculator right here? What trig do you have to use to solve for x? If I say the cosine of x is equal to something, how do I solve for x? X is an angle. How do I solve for angles?
Don't you have to do the inverse cosine?
Correct. You always take trig functions of angles to get ratios. You always take inverse trig functions of ratios to get the angle. So if I take the inverse cosine of minus 1/2, go ahead and do that on your calculator.
So it equals 120.
Make sure you're in radians, because all my answers are in radians.
So 2.
Keep going. Not 2.
2.1.
So when you're in radians, your calculator doesn't give it to you in terms of pi?
No.
Okay. So your calculator gave you 2.1, right?
Mm-hmm.
Radians. Is this a possible answer?
I'm not sure.
What's pi?
3.14.
What's that divided by 6? It's not 2.1.
It's 0.52.
So that can't be an answer. What's pi divided by 3? Is that 2.1?
No, it's 1.
Pi divided by 2, not 2.1. What's 2 pi divided by 3?
2.1.
Ah, so one of these two is the correct answer. Now, that's pretty good. We've reduced it from a 20% guess to a 50-50 guess. And that's probably all the better you're going to be able to do on this. Now, the key thing to understand is that when you put that into a calculator, it doesn't give you both quadrants. You've taken trig, right?
Mm-hmm.
Okay. Now, remember your unit circle. You got 4 quadrants. Cosine is negative in both the second and the third quadrant. Your calculator only gives you the second quadrant answer. That is the second quadrant answer, 2 pi over 3. But the fact of the matter is that there's also an angle in the third quadrant. The cosine of that angle is negative 1/2. That's 4 pi over 3. So to really understand this problem, you have to know that, first of all, cosine, all students take calculus. So cosine's positive there, and it's negative there and there, right?
Mm-hmm.
Well, 5 pi over 3 is in this quadrant there, the fourth quadrant. That can't be an answer. That is third quadrant. That is second quadrant. So J is the correct answer, but there was a lot that went into this. You really almost have to have taken trig to get this. The people that just got 1 week's worth of trig from algebra class aren't going to be able to get this. They might be able to eliminate these 3 answers and guess between those 2, but they're going to have to know the unit circle and where each trig function is positive and negative. They're going to have to know all of that to be able to distinguish between J and K. The key thing to understand is that your calculator doesn't give you both quadrants. It only gives you one of them. So know that. And yet they wanted both of them. They want all the answers that are in the unit circle, and there's going to be 2 quadrants, 2 angles, whose cosine of those angles, in other words, if you go backwards, and go ahead and try it. Put the cosine of 2 pi over 3 and make sure the 2 pi over 3 is in parentheses. What do you get?
Oh, 1 second.
Cosine of 2 pi over 3. And you can use the pi key. You don't have to use 3.
Negative 0.5.
Aha. So that's answered. Now, guess what? I can back solve this. Once I get it down to those 2 answers, well, now what's the cosine of 4 pi over 3 in your calculator?
Negative 0.5.
Bingo. That's our answer. Now take the cosine of 5 pi over 3. What do you get?
.5.
Ah, positive 0.5. That can't be an answer. In other words, you really didn't have to know the unit circle. You just had to be able to differentiate knowing that those were the only two possible answers, because we know one of the answers has to be 2 pi over 3. But the second part is 4 pi over 3 correct, or is 5 pi over 3 correct? And you can answer that by the method you just did. Find out what the cosine of 4 pi over 3 is. Find out what the cosine of 5 pi over 3 is. That will give you your answer.
Okay.
With 100%. In other words, if you've done that analysis, you could bet your life that this is the correct answer, even if you don't know this unit circle. You don't need to. Just check in your calculator. You could actually solve this whole problem that way. It would just take a long time. In other words, you could just go through f. What's cosine of pi over 6? It's not minus 1/2. That's wrong. What's cosine of pi over 3? It's not minus 1/2. That's wrong. Same thing there. And now when I get to j, what's cosine of 2 pi over 3? It is minus 1/2. Well, now what's cosine of 4 pi over 3? That's also minus 1/2. I got my answer. It wasn't really that hard to do by back solving. So I've just shown you 3 different ways you can solve this problem. Back solving might be the quickest. In other words, just start your answers. Take the cosine of that first angle you see there and see if you get minus 1/2. If you don't, that can't be the answer. This is another good problem. 43. Easy, medium, or hard?
I don't know. I'd say pretty easy.
Okay. Is that quadratic factorable or not? Without
No.
trying.
You'd have to do the quadratic formula,
No,
right?
don't. The reason I know it's factorable is because they gave us one solution. One.
Oh.
Whenever you use the quadratic formula, you always get answers like square root of 7, plus or minus square root of 7. You don't get whole numbers. If you use the quadratic formula and you get whole numbers, that means it was factorable and you didn't need to use the quadratic formula. So, I can factor that thing. I know it. What's one of the factors? What does that mean? What does one of the factors have to be?
-1.
No, x minus 1. In other words, it's one thing saying that that's a solution, but that being a solution, here, let me explain it a little more. If I told you this, how do I solve for what the solutions are?
Set it equal to 0.
Set each one equal to 0. So x minus 7 equals 0, so x equals 7. So now let's work backwards. If I tell you that x equals 7, that means one of the factors is x minus 7. So I can immediately go up here and write x minus 1 is one of the factors. Now getting the second factor is pretty easy, right? What's got to go here? Let me point this way. What's got to be that first term in the second parentheses?
X.
No, it's got to multiply to 5x squared. Got to be 5x. Remember, that first term always comes from multiplying that times that, the f of FOIL. What's the rest of that second term? How can I produce a minus 7? There's only one way. Remember, the minus 7 comes from the last two numbers, the L of FOIL. Well, it's got to multiply to 7, right?
Mm-hmm.
So that's got to be it. I know the signs have to be different because it's a -7. And I know that these two numbers have to multiply to 7. So I'm certain that it's x minus 1. And once I have one of the factors, the second one is pretty easy. So all I got to do is figure out what x multiplies by to get 5x squared, and that's 5x. And then what does minus 1 multiply by? To get minus 7, it's got to be plus 7. So now I know that's the other factor. So what's the other solution? If 5x plus 7 equals 0, what does x equal?
Negative 7/5.
The reason I like these problems is because they give you these huge concepts. When they give you one solution and it's a whole number, that tells you it's factorable. It tells you you do not have to use the quadratic formula. This would be almost an impossible problem to get if we had to use the quadratic formula. I've got to be able to come to the conclusion that that makes a linear factor, and that means that thing is factorable. So all I got to do is figure out the second factor. And if you know one of them, the second one's actually pretty easy. In other words, if I gave you the quadratic and I said factor it, well, that's a hard problem. But if I give you this quadratic and I give you one of the factors, then it's an easy problem. It's a piece of cake after that. You just have to know that if you have a solution, you have to take that linear solution, that solution and convert it to a linear factor.
Okay. Okay.
You ready for a break?
Well, we only have 10 more minutes, so.
Oh, you're right. I was thinking we started at noon. Yeah. Time flies when you're having fun. I didn't think at least for me. But I didn't realize we'd gone that long. Okay, well, we might as well finish out then. 44, the moment you see parallel, you know it's a parallel line transversal problem. Okay, well, this one they make particularly difficult because PS is parallel to QR, and you got two transversals. You got both diagonals or both transversals. So the trick is going to be kind of to eliminate one from your mind. Well, let's label up our diagram. That's PST, 65 degrees. QRT is 35 degrees. So that's what we know. And they want to know this angle right there, PTQ. Easy, medium, or hard?
That's a medium.
Okay. Give it a shot. Now, it's a geometry problem. We know for sure, especially if you think it's medium, that you're not going to be able to get question mark step 1. You're going to have to figure out some other angles. Well, what have they told you? They've told you these two lines are parallel. That is rarely irrelevant information. When they tell you lines are parallel, it's almost always necessary information.
Oh, so would that mean that
That angle right there
is 65?
Now the problem is easy, right?
Mm-hmm.
What's this angle right here?
Um, 80.
So what's the question mark angle?
100.
Again, utilize the fact that they've told you they're parallel. That's going to allow you to figure out another angle, and once you figure out just one other angle, now you can figure out the third angle and the angle in question. All right, 45, easy, medium, or hard?
I don't know. I haven't read it yet, but I feel like it should be easy because it's such a long problem.
That's actually a very good point you make. But in this case, that's not true. That's sometimes true. But the more lines are in the problem doesn't make it harder. but this is a distance, rate, time problem. Okay? I guarantee you every distance, rate, time problem you come across is going to be hard.
Okay.
First of all, let's start with the most important thing for you to know, which is the general formula that relates distance, rate, and time. What is it?
Distance equals rate divided by time.
No. There's a super easy way to remember that. Dirt. See how you can't go wrong if you always remember dirt?
Mm-hmm.
This is not dirt. This is not dirt. Only this is dirt. Now, you can manipulate this as many times as you want. In other words, you can figure out that that means that R must be D over T, or T is D over R. In other words, there's all kinds of algebraic manipulations of that. But you have to know the original. That's the only one you want to know. That's the only one you want to stick in your memory. You don't want these other, you don't want that in your memory. That means you got to remember 3 or 4 different formulas. You just got to remember one formula, dirt. The equal sign replaces the I.
Okay.
Now, that's a help, but it's not a complete solution. But it's a start. This is still going to be a hard problem, even if we know dirt. This is definitely one that if I'm taking the test, I put a double check mark and I come back and make sure I don't try this problem until I know I got time, extra time. Okay? For some reason, the ACT does not give you simple dirt questions. They could easily give you simple dirt questions. If I go 60 miles an hour, how long does it take to get to Pueblo, which is 120 miles away?
2 hours.
Okay, what you did was dirt. The distance to go was 120, the rate was 60, and we ask about time. So time is 120 divided by 60, 2. That would be a simple dirt question. They never give you those. I've never ever seen a simple dirt question. The only dirt questions I ever see are these super hard ones, where they got 2 people either going in opposite directions or moving together, where 2 trains cross. Since we're almost out of time, I want to wait on this one and come back to it so that we can give it the proper time it deserves to figure out how to do it. You can also back solve these. This one is very back solvable. You can just start with the answers and see if everything makes sense with those answers. But it's definitely a hard problem. It's going to take us 1.5 minutes to 2 minutes to solve, even if we back solve it. Or if we try to algebraically solve it, it's going to be even harder. So I would almost say that the best way to solve it is back solving it. But even with back solving it, you need that.
Okay.
What's that?
I said okay.
Okay. All right, let's stop there. That's plenty for today. And we'll pick up with this problem on Friday.
Okay, perfect.
Just make sure I've got the right time down. Friday at 2:30, correct?
Mm-hmm.
Good. Haley, I'm impressed with your endurance.
Thank you.
It's not easy to do 2 hours of math in a row for any.
It is not.
No, it fries the brain. You might have to go take a nap. Being a little facetious, but it's definitely hard to do math
Yeah.
2 hours in a row. So, but it's good.
True.
It's good for you because you do have to learn endurance. That is a long, grueling test. And even though you only do an hour's worth of math, you're still doing all science and reading and all the rest of it. So it's still a grueling test.
Mm-hmm.
I will talk to you Friday, Haley.
Okay, perfect. Thank you so much.